For this physics problem, we'll be dealing with an inclined plane. We're told that a box of mass m is on a rough inclined plane that has an angle theta with the horizontal. A force of magnitude F at an angle phi with the plane is exerted on the block as shown. As the block moves up the plane, there is a frictional force between the box and the plane of magnitude lowercase f. What is the magnitude of the net force acting on the box? So the first thing we'll do is copy this diagram that we're given and draw a free body diagram. The first force that's going to be acting on the box is gravity, which is mg. But since we want all of the forces to be acting in the same direction, I'll draw a coordinate system which we'll be following. This is our x-coordinate in the positive direction. This is our y-coordinate in the positive direction. Now we'll want to write all of the forces out. Breaking up our mg force into different components, and then recognizing that this angle is theta, we can write mg cosine theta and mg sine theta as the two components of the mg force. We also know that there's a normal force acting on the block as well, and I'll call that N. The next force that we're told is that there's a magnitude of F, lowercase f, which opposes the direction of motion, and that's our friction force. Now for the tricky part of the problem. We need to break this force up into its components, where this is F sub x and F sub y. Now by using trigonometry, we can write that the cosine of phi is equal to fx divided by f, and sine of phi is equal to fy divided by f. So we can write that fx is f cosine phi and fy is f sine phi. Now that we have all of our forces drawn, let's write Newton's second law, which says that the sum of the forces is equal to mass times acceleration. Now, since the block isn't floating off of the ramp or going into the ramp, we know that the sum of the forces in the y direction is going to be 0. So we'll focus on the sum of the forces in the x direction. Looking at our diagram and remembering that for our direction notation, up the ramp is positive, we can write the fx magnitude minus the frictional force minus mg sine theta, because if you were to draw this force up the ramp, it'd be here. Equals ma. And we know, because we calculated it, that fx is f cosine of phi minus mg sine theta minus f. And this is the magnitude of the net force acting on the box. And that's it.